Kia ora, I'm Dr Craig Depree. I'm a freshwater scientist at DairyNZ based in Hamilton. I'm here with dairy farmer Helen Brown in Walton, and we're about to use eDNA sampling kits to find out what's living in the stream behind me, the Piako Nui, flowing through her property. And we're going to sort of use this eDNA kit to have a look at the fish that's in there, and also to give us an idea about the overall sort of stream health. So Helen, have you heard of eDNA before?
Yes, I've heard that the sampling can be done, but I've never ever seen it done before.
Yep. Well, eDNA, it stands for environmental DNA, and basically that just means if you look at anything behind us, whether it's the trees, obviously fish, anything in the rivers, it's all shedding a bit of DNA, and that's going to go into the stream, and that's what we're going to put out a sample to catch. These kits cost around $300, and they're available from Wilderlab, so you can go online and order these kits and then also submit them all online. It's actually sort of quite easy to do. Once you get the kit and you come down to the river, you open up the kit. It's important that we put on gloves because we humans tend to sort of let a lot of eDNA out. We get the sample out, and then we walk into the stream and we find a secure spot to sort of push it into the stream. You get provided with a tent peg, a small tent peg, so if that's suitable for your stream. If you've got faster flowing water or deeper sediment, you might want to use something like a waratah and a cable tie just to attach the sampling unit to that. And then you leave it in there for at least a day, 24 hours. It can be more. The longer you leave it in there for, it absorbs just more eDNA. So the next day when you come back and it's been in there for at least 24 hours, then you're going to come back down. You've kept the Ziploc bag because that's got another pair of gloves in it, so don't use the old ones. You get the new pair of gloves out of the bag, put those on, walk into the stream, and then you retrieve that sample, come back to the bank. There'll be a little nylon string coming out the back. You pull the foam plug out of the sample holder because that's what's storing all the DNA. There's a screw cap container inside the packet. You take the lid off, push the foam plug in there, then you get the syringe with the all-important DNA preserving solution, squirt that into the container, put the lid back on tightly, shake it all around, make sure that that solution's spread through the sort of foam plug. Then you pop it in the packet, then you go back to Wilderlab, you submit online, and then you go and post that back to them, and then you sit and wait for a couple of weeks for your results to come back. Thanks for your time, Helen. The two things that are really, I guess the two things that we sort of like to run that eDNA is giving us is a list of all the species, and certainly, I guess more importantly, those species that tend to sort of matter more to farmers and communities, and that's fish. And then the other thing that it provides us is that with all the information that it collects of all the different types, the plants, the insects, the fish, it puts that all together and it just gives you an estimate of what it thinks the overall stream condition is. The encouraging thing though is that we actually see all the same species that we saw upstream are still present down here. Upstream, which is a reference site that had kind of what we'd probably consider excellent or very good water quality, but the water quality, the overall score is still telling us that it's good here. We see a banded kokopu, and that's one of these fish that do like to have forest canopies. We saw that up at that sort of higher, at that other site, but at your site we're still seeing banded kokopu there. And from your own observations, I think you've seen quite a few other things. We saw the fish, the eels, and the other things we've seen that are still good indications of what we want to see in streams is freshwater mussel, the kakahi. So having a bit of a download there of what's there. So do you have any thoughts about what the results have sort of shown you? Any inspirations?
The biggest challenge I find is how do we provide the best habitat for what we have got in our streams, and how to increase the water quality, and what's the next best step forward for the catchment?
In terms of what we know that existed here before, we know that streams were shaded, and shaded provides a lot of sort of benefits for fish. It's probably not so much of an issue for you, but further downstream, that the absence of shading really causes a lot of problems with weeds growing in the streams, warm temperatures. So the further that, even if you're shading your stream up here and providing habitat, it's going to have flow-on effects down the catchment. It really is about getting the whole catchment involved. Certainly in terms of shading, there's that general rule of thumb that you should have a tree about as high as the stream is wide, and that's going to provide you with this magic number of 70% shading.
It's really exciting to actually see that is actually healthier than we thought it might have been. Like there's a really neat base to start protecting a little bit better than what we currently have been.
Well, thank you, Helen, for letting us come out here and go into your sort of these farm streams and sort of start you on your journey.
Our pleasure. Anyone that can help us and guide us on our journey as well is very much appreciated. Thank you.
If you're interested in taking an eDNA sample from your local stream or your catchment group, go to waterlab.co.nz and follow the instructions there.